You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. To answer these questions, we need to consider the given conditions. The first one is that the cosine theta is square root of 3 over 2, but the tangent theta is less than 0, and that the theta is just between one revolution on our unit circle. Let's consider this unit circle here. As mentioned, one revolution of that is 2 pi, and since it's positive, so we're moving counterclockwise. Okay? So we know that our cosine is square root of 3 over 2. Okay? That would mean it's closer to 1, so it's just somewhere here or even here. So our terminal point of our theta, that's the first question we're trying to solve, is somewhere or just between these two. It's either here or that. But we can determine that by further checking or verifying the conditions. We know that this is the, on our unit circle, the square of x plus the square of y is equal to 1. And its illustration using trigonometric function, the cosine square theta, okay, that's the square of cosine, plus the square of sine theta is equal to 1. To determine the sine, because we're solving for sine first, even if it's not what is asked here, we are going to solve for sine such that we could determine which point or which terminal point we are referring to. We already have our cosine being square root of 3 over 2, and we're going to use this formula or identity to solve for sine. We know that our cosine is square root of 3 over 2. That's positive. Plus our sine, that's a square, sorry. And we have here sine squared theta is equal to 1. When you have this, the square of square root of 3 is 3. The square of 2 is 4. Plus, you have here sine squared theta equal to 1. Subtracting 3/4 on both sides, your sine squared theta is equal to 1 minus 3/4, which gives us a result. Okay, sine squared theta is equal to 1/4. Then let's take the square root of both sides because we're solving for the sine, not sine squared. So you will have here positive, negative. You're taking the root of a number. So we have here 1, 4. Or this is equal to positive and negative. Square root of 1 is 1. Square root of 4 is 2. There are two possible answers for our sine. Okay? Positive 1/2 or negative 1/2. But the thing here is that we have the condition that the tangent theta is less than 0. We know that tangent theta is sine theta over cosine theta. This would mean that entire expression is less than 0. Our cosine is given as positive square root of 3 over 2, so that's positive. What should be the sine of our sine? Okay, that's a pun. What should be the sine of our sine theta? such that when we divide that to positive, it's still less than 0. Less than 0 means negative. If we are going to take positive 1/2, positive divided by positive is positive, this will not be satisfied. This would mean we are only going to accept the negative of 1/2. In short, the final answer for our sine theta is equal to negative 1/2. This would mean we are choosing this point here, which is, or somewhere here, sorry, which is negative 1/2, and you have your square root of 3 over 2. So our theta, its coordinate is again a combination of square root of 3 over 2 and negative 1/2. Our theta here could be both ways. We could have two possible answers as well. The revolution from this to that counterclockwise means positive, and we have here the clockwise, which is negative. However, we also have one restriction, that the theta is just between 0 and 2 pi. So we're talking about positive. If you're going to observe this carefully, our theta is actually equal to 11 pi over 6. Okay, because this is a multiple of pi over 6, and we just have it here. So before pi over 2 pi, we have 11 pi over 6. So the coordinate of 11 pi over 6 is equal to this one here, square root of 3 halves and negative 1/2. And with that in mind, this is now our A, by the way. Our A is this one here, 11 pi over 6. Let's proceed to our B. Our B is cosecant theta, or let's specify the theta here. Cosecant 11 pi over 6. Cosecant is actually the reciprocal of sine. So you have 1 over sine of 11 pi over 6. Our sine is already given as negative 1/2. So you have 1 over negative 1/2. We could have this 1 over 1. So we'll have keep change method, 1 over 1, change the operation to multiplication and reciprocate this, 2 over negative 1. Hence, our cosecant 11 pi over 6, or cosecant theta on what is asked, is actually negative of 2. Okay? Let's proceed to our last, which is the cotangent of 11 pi over 6, or cotangent of theta. We already identified it's 11 pi over 6. This is actually, since we don't have tangent, it should be the reciprocal of tangent. But since we don't have tangent yet, it's just a combination of cosine 11 pi over 6 over sine 11 pi over 6. Okay? Our cosine 11 pi over 6 is already given. We have square root of 3 over 2. And our sine is negative 1/2. Okay? Surprisingly, we have the same values as the previous video, but we have different trigonometric functions. Either way, let's just continue this one here. Keep change flip method. Negative 3 over 2. Change the operation to multiplication. You have 2 over negative 1 as we flip our denominator. Cancel. Cancel. Negative would be placed on square root of 3. So you have negative square root of 3 for the cotangent of 11 pi over 6. So we're able to solve B and C together with A as we done finalizing what should be the value of our sine, which completes a certain coordinate of our theta, because we are also considering the conditions given. Thank you for watching.